Hi everyone, my name's Scott. I was doing this video last week and I put it up on YouTube and got a number of views, which was awesome. But then, sort of after I put this video up, I got a bit of feedback telling me that some of the code that I wrote was probably not good practice, and I completely agree with those comments. I was in the middle of a game jam at the time, and sometimes these things happen. I was having weird coding juju and I couldn't get what I wanted working to work properly. But I figure if this is actually a useful resource, this video, I should probably redo it. So for those who didn't watch the last one, basically what I'm attempting to do with these video tutorials is help people juice their game. That's a term that I heard on Reddit and sort of also watched a few videos on YouTube about. And juicing is basically just making your game feel good, feel better. And doing it, I guess, in ways that are really simple, that don't take very long to implement, but make a huge difference. In fact, I'm currently writing a game at the moment for one of my uni assignments, and I'm spending the majority of my time at the start of my development process adding all this juice to work out if it feels good, because if it doesn't, I'm going to stop and make something else. Normally I'd persevere and then at the very end try and make it feel fun, but I'm tackling it from a different perspective, and it's actually making coding a lot more enjoyable. So that's what I'm basically teaching people today, that as a programmer you can add a few really simple touches that make your game feel so much better. It makes you as a programmer enjoy what you're doing so much more. It's nicer to look at. I don't know, it makes you feel more accomplished. You don't have to rely on other people as much to get this stuff in the game. And so I'm going to spend some time showing you how to turn these power-ups, these awesome 3D models that my friend Werner made for our game jam, just make them feel a bit more fun. So I mean, this is a really cool looking model. I love that base. But by themselves, these power-ups are a little bit boring. I know they don't have any functionality, but we'll add that functionality as well. So I'm going to use the speed power-up, which is this one here, as an example, and I just want to show you how it's constructed so you've got a good idea of how these objects work. So we have our base object, nothing special there. There's nothing attached to it at all. You can drive over that or drive through it so you don't bounce over it. It's just there for looks. And then we have our chevron object here, which I've added a box collider to, which I've set to as a trigger. You could probably use standard collisions for this. I don't know why you'd want to use physics collisions really, because we're not doing physics on the actual object, but you could if you wanted. I just like triggers because I think they're easier to deal with. And I've already just on this object attached a power-up script. So my shield, for example, doesn't have the power-up script on it. It's just got the box collider. And the power-up script is what we're going to be using to give this object some life and make it feel good. So the power-up script that I've got here in my scripts folder, so if I go into my scripts folder, you can see I've got a power-up class here. In my previous video, I released a Unity package to sort of demonstrate the code for this. I will probably re-upload that Unity package and make it this new one to make sure that the code that I'm using, pardon me, is up to date, because I don't want to give you code that was wrong. As a result, though, I sort of have preceded some of this information that I did in the last video to save some time. So this power-up script is going to be used as the parent script that we apply to any power-up in the game. And that's going to make them all look exactly the same, because that sort of makes sense, right? Then we have this visual cue of, oh, I know what this thing does because I've run into others that give me power-ups. Then what we're going to do is we're going to override these in this behavior in child classes to actually add the functionality that makes the card do what we want. I'm only going to do that for one power-up just to show you how it would work, and then you can sort of extrapolate those ideas to all the power-ups if you'd like. So I'm just going to open up this power-up script and run through that super quickly, and then we'll get into it because that's the fun stuff, right? So Visual Studio always takes a while to open the first time. So this is my base class that I've already set up on my parent class, and I've just preceded it with a few variables that we're going to be using. I've got an original scale variable here. It should be pretty obvious. I want to record the original scale for the object. The reason is I'm going to be scaling this later. Depending on what size your scene is will depend on how big you have to scale the object when you want to use it. So for example, the original 3D objects that I'm using were quite small when I originally imported them. I scaled them up in the import settings, but then I also scaled them up again in scene. And so because I don't know what size they're going to be, if I just cache their local scale or their original scale, then I've always got it handy, and then I can just scale it back up, and it makes my life easy. Because we need some sort of implementation later, the way I'm going to do that is by checking if the cars run into the collider, that box collider we were talking about with the trigger on it. So I'm just going to grab that collider and use it later. It's going to make my life easier. I don't like that I've got the new keyword there, in fact, so I might just do that, call it col, and that should fix that issue up. I don't like hiding things by accident. In fact, that should probably be protected as well. Actually, no, it doesn't need to be. Okay, and then I've got a bunch of private variables down here. Some people might not have seen this serialized field tag before, attribute. I think it's actually called an attribute. Basically, most people, when they do tutorials, they expose their variables in the inspector, and by exposing them in the inspector, I mean doing this sort of stuff here, showing them by making the variables public. I don't like doing that because you're not really supposed to, I guess. It's not, I'm using air quotes, you can't see them, but it's not good programming practice to do that, right? We don't need to access these variables outside of the class, and therefore they should be private, and using this serialized field attribute is a way to expose them in the inspector without them being available to other classes. So let's get started and actually make this fun. So what I'm going to do here quickly is grab that original scale that we were talking about before so I can use it later, as well as grabbing the collider. Now I am using a new keyboard for this, so apologies if I make some typos and stuff. I'm still getting used to it. So there we go. I've quickly grabbed everything that I need. Oops, sorry, I changed the name of that. For those who haven't seen these keywords before, protected basically means that not only will this start function be used in this version of the class as in the parent version, it's actually going to be accessible and usable in old child versions of the class as well, which is really useful. And any class, or sorry, any function, not any class, any function in the class that I think I'm going to need to override later, I am calling virtual. And that basically lets the compiler know, hey, later on I might need to override this functionality, so use that version instead of this one. I'm not probably going to override the start function now, but I think it's good practice in case I ever need to. So now I've just cached some values that I might need to use later, and let's actually get on to making it move. So I'm going to do the same thing here with my update function, which again I'm actually not overriding for the sake of the tutorial, but now I have that option. Now, what's the first thing we can do that's going to be really simple, really fun, and just give it some life? Oh, I can make it move. Now, I don't really want to make it move away from the base. That would be weird because the base and the power up are sort of, they come as a package. So a simple way to make it move would be to rotate it. I'm going to do something really simple here. I'm going to grab a new vector 3. I'll just seed these with all zeros for now, just so I don't get errors. And that's not going to do anything. But what I want to quickly show you is, for those who don't know, you can see here that if I grab this object and move it, Y is the up direction. And that doesn't want to undo, there we go. Now, because Y is the up direction, this one here, that's the axis that I want to rotate it around. Oh God, what have I done? That's the axis that I want to rotate around, right? So in here, we can change this variable, because this is the axis that we want to rotate around, and make it do something. Because we're in the update function, we're only moving in fractions of a second, so we'll always use time.delta time as sort of a multiplier, so we're not moving in really big jarring chunks. And then as you can see, I've already got a variable that I've saved already called rotation speed, and I've saved a value that I like the feel of already. But basically all this is saying is transform my object around the y-axis by 25 times by delta time. Now when we run this, look at that, it's spinning, and that's already feels pretty good. Like even in the game view down here, I know it's small, I'm going to keep it fairly small. That just feels really good. Like you can see it moving, and you sort of want to head over that way and check it out because it's doing something the others aren't. And that was like really simple. That's one line of code, and now we've got this object moving. But we can do better because, you know, that's not that great. So the next thing I'm going to do is I'm going to grab the position of the object, and I'm storing this in a temporary vector3 called position because I can't directly manipulate single axes of the transform position component, which is quite common. So I'm going to instead do it this way. I'm going to say that the position of the object is equal to time.time since level load plus time dot delta time divided by double amplitude. And then we're going to do exactly the same thing underneath, except we're going to add a position, and then we're going to set the transforms position to be that new position. So just quickly, what I've done here is I'm going to make the object bobble. So that's what these 4 lines are doing, is it's going to make the object move up and down. So if no one's seen a sine wave before, it basically gives you a figure between +1 and -1 on the y-axis for any value of x. So what I'm doing is I'm grabbing the object's current position. I'm then basically, this is a bit silly, I'm basically undoing the last operation, which won't exist for the first frame, and then I'm re-adding the new one. And basically what I'm doing is I'm basically always taking its original position, I'm offsetting it by whatever value of x we're doing, and then next frame I'm basically taking that old value away and then re-adding the new value. And the reason we're doing that is I was told by a friend, if you sort of just incrementally add your positions every time, because we're always dealing with adding up floats, they're probably never going to equal 0 again. And if you've got a really long game, say you have like a half-hour free-for-all game, these power-ups might actually start creeping up in the y-axis, and then we might have issues where our cars don't run into them properly because they're sitting too high off the base. So this is just a nice trick way to sort of always position your object relative to its original position. And basically I'm just pumping in time since level load. As I said, it can be any value of x will give me a value of y between -1 and 1. So I might as well use time since level load because that's always changing, and it will always keep going up, and I'll never get the same value. So now when I run this code, it now bobs up and down as well. And that's really cool. And I'll just quickly jump back here. You can see that what I'm doing is I'm basically getting is a number between 1 and -1, as I've said, and then I'm multiplying it by this bubble amplitude variable that I created. So again, because my scene is quite small, I don't really want it to move a whole unit, up one whole unit, because that would be too big. So if I change this bubble amplitude here to 1, it's going to fall into the ground, which doesn't look very nice. So this just gives me some fine control over how much I want it to bobble. See, now I've broken it. Now it's not moving at all. But I can change that. I can say, oh, well, from here I actually want it to bubble 0.5 instead of 1. And that sort of just goes into the ground. So that's not very nice either, right? So maybe I might be able to get away with 0.4. But I could make it even smaller and just make it 0.1. And it would just sort of wobble just a little bit, just so it feels like it's got a little bit of mass. That just makes it feel so much nicer. I'm going to set it back to 0.3. But as you can see now, the spinning was okay by itself. It was it felt alright. Now it just feels like it's sort of floating or hovering on that base. Like it really feels like it's got some weight to it, and as it's twisting, it's sort of falling down in the base, it's pushing it back up, because that sine wave has a really nice ease in and ease out. So again, that's really only 5 lines of code, and I could probably make it shorter if I wanted to. That just really makes that feel nice. It's got some character to it now, and it's moving really well. So I'm going to create another function now called onTriggerEnter. I'm going to make sure we can access the collider for that. So this one here is the big one. So this one is the one we're going to override in the child class, because this is the one that gives us our functionality. So the first thing I'm going to do when we run into the object is, I'll stop calling it collider, is I want to disable the collider. The reason I'm doing that is I don't want someone else to run into it, or even the next frame for me to run into it and then re-trigger the power up again. So the first thing I'm going to do is disable the collider, and now the object, this function will only fire once, which is really, really useful. Now, pardon me, we need to do something with it, right? We need to let the user know that, hey, this thing's been disabled. So I guess the easiest thing to do would probably be is to do the same thing for the transform. That's actually not the transform, it's the game object. We can turn it off, for example. So hopefully this will work. I haven't actually tested this. This would be a good idea. Once my code compiles, I can hit play. I want to drive into this object, and it disappears. And that's cool. Like, it's gone. I know I've run into it. So that's like a nice heads-up display to the user that, hey, you've just done something. But it's still a bit boring and a bit flaky. And I don't know. I think just any jarring transition is really not good in games. Like, it's really easy to add a fade or just do something really simple. So I'm going to do exactly that. I'm going to change the way the object works. And I've decided that instead of doing a fade, I'm actually going to scale the object. And that's why I have the scale speed variable up here, because I think scaling is, I don't know, just a bit fun, a bit different. I used fades for other things, so I thought I would do that. Now this is going to be a private function because I don't need my child classes to access it, and it's going to be a coroutine. So we needed to return a variable of enumerator. We're going to call it scale object, and I'm going to add a target variable straight away because I've already done this before and I know I'm going to extend it. So a coroutine, for those who don't know, hopefully you know, because coroutines are amazing and you should be using them, is they allow you to do an action over a number of frames. So much like the update method, I can call this function and say I want to start at this sort of condition and finish at this condition and do it over X number of frames. So the first thing I'm going to do is grab the scale of the object. Because that's important. I'm going to scale the object. Initially with this function, what we're doing is we're scaling it down. So currently the scale is, let's say for all intents and purposes, it's 1, and I want it to get towards 0. So I'm just going to make a quick while loop that says while my scale does not equal my target vector 3 that I'm going to place in, scale it down. So scale equals vector 3 dot move towards. Now what are we moving? We're moving our scale towards our target, and now here we've got a max distance delta. So how far do we want to move per frame? Well, again, we're working in fractions of a second because we're working in frames. So let's move by time dot delta time multiplied by our scale speed variable. That way we can tweak the speed at which we scale the object. So now it's going to keep scaling down every frame as we get towards our target scale, which is going to be 0. That would not be very useful unless we set that new scale back to the object. So set the object scale to the new version, and then let's wait for the end of the frame. So all this is going to do is it says, give me a target scale, so let's pretend that's 0. Get my original scale, let's pretend that's 1. So while 1 does not equal 0, have my scale move towards 0 at this speed, set that new scale to my object, and basically keep going until I get to 0. So now I have a coroutine that's going to just shrink the object over time and not make that transition when I run through it as jarring. And to call that, it's as simple as saying start coroutine scale object. And now the scale object function needs a vector 3. We want it to scale it towards 0, and there's a built-in vector 3 for that. So now I can call vector3.0, and it's going to take the original scale of my object and keep dropping it down until it's nothing. So now when I run this, what's going to happen is I'm going to run through it, and just see how it shrinks down? It just feels a little bit nicer now. It's not so quick. You know, you could add a sound to that if you wanted to, or add particle effects, but that's what I'm getting at. You don't need to worry about any of that if you just want to juice real quickly. Just add some code in to shrink that chevron down, and that already just feels less jarring, and you can sort of see the effect that you've had by running the object over. But I've got a problem with this code. I run over this power up once and it's gone. Now, I watched a really interesting video by one of the members of Lambir the other day, and he made this comment that I think was sort of, you know, off the cuff or as an aside, but really struck me. He was showing a demo of a game where people shoot bullets, and he said that you should make shooting bullets happen the most, you know, really quickly all the time and very fast, because that's the core part of that game. So that should not only happen a lot, it should also feel really fun, which, you know, is pretty obvious, but I think we forget that sometimes. And that's the same with these power-ups. Like, we should let people use them as often as we can and as much as we can. One of the problems I have, though, is I've now run over this power-up and I can't use it again. It's done. That's a little bit pointless, isn't it? So let's add some code so I can respawn this object, you know, at a sort of semi-regular interval. So again, I'm going to make another coroutine because coroutines are amazing and they let you do all sorts of things like run delays. And I'm going to call this respawn object. And the first thing I'm going to do here is I'm going to make it wait. That's not how you spell yield. I'm going to make it wait for a random number of seconds. Okay, so random.range. And in case you didn't notice them before, I actually made two variables up here called min spawn time and max spawn time. So what all this coroutine is going to do at the moment is it's going to wait for a value between 5 and 15 seconds. And once it's obviously random that number and waited that long, it will then run the rest of my code. So all I'm doing here is just adding in a really cheap, simple, you know, worry-free delay. And then I'm basically going to call exactly the same scale object coroutine that we've got up here. So originally we called it, so let's say our scale was 1, it's not, but let's say our scale was 1. We put in a target of 0 and it scaled it down. Well, now our scale is 0, so if our target is the original scale, which is why I cached this up here, then this function should do the opposite. It should go, okay, well my scale is currently 0, 0 is not equal to 1, so do the opposite, let's scale back up towards the original size. We're almost done here though. We haven't actually called the respawn object function anywhere. And I'm going to do that here in my scale object coroutine. And I think the reason I'm going to do that is because I can delay all the functionality for the, you know, respawning, all that sort of stuff until after the animations are finished. It's a really simple trick. So I've got two states really. If my object is scaled to nothing, if I can't see it, if it's vector3.0, then I want to start the coroutine that respawns the object, which makes sense, right? Because we want it to come back. So if once it's scaled down, call this coroutine, which is going to wait for a random number of seconds, and then it's going to call this to scale it back up. So the other option, I really don't need an if statement, but I'll do an else if to make it more explicit. The other case we'll have is if our scale is the original size. So instead of scaling it down, we've scaled it back up, and now we're at our original scale. Well, there's only one thing I really need to do now it's back, and that's just re-enable the collider. because if I don't re-enable the collider, I can't run into it again, which won't call on trigger enter, which won't scale the object back down. So again, 2 lines of code. It's giving me a nice sort of pseudo random wait here, and then a couple more lines will just allow us to make this a stateless, constantly replenishing object. So I'm going to run this code. See here, I'll drive through it. It's disappeared. If we look up in the scene view at the top, it's probably a bit easier to see that after a random amount of time, that object is going to hopefully scale back up. There you go. And that just feels pretty nice. It's really easy to do. The player knows they can interact with it again. There's no like state checking or anything. It's super trivial. It's super easy. You can't break it. It's just done. So this is, less than 55 lines of code with all my variables and everything, and I've taken something that was, ostensibly pretty boring over here. That's pretty boring. There's nothing wrong with that shield. It's not enticing. And then this over here looks way better, and it's even just running into it feels nice. There's just something about that object that now feels like it has some sort of, I don't know, weight to it, some realness to it. So that's really cool, but it doesn't actually do anything. So let's make it do something quickly. So we're going to create another C# script, and I'm going to call this speed power up. And I'll open this. So as I've mentioned, this speed power up is a power up. That's the whole point. So this is no longer a mono behavior, it's of type power up. And because of that, if I go to this speed power up now and I check our chevrons, I've got this power up script here. Well, that's pretty generic and it doesn't actually do anything. What I really want to add is my speed power up. You can still see I've got all these variables available to me from the power up class because speed power up extends power up. So I do have all these available to me. Although really they should probably be protected. That's a bit weird, isn't it? Shouldn't they be protected? I'll make them all protected. I feel like they shouldn't be private. I'm surprised they even show up. Oh no, it's going to do that, isn't it? Mess up my nice formatting. That's fine, I'll do it like that. That's what they want. So what we're going to do is something really, really simple. So this speed power up, all we're going to do is double the car's speed at, whatever their speed was when they passed through it, which probably isn't a great way to do it, because if they're already moving really fast, they might move so fast that they can't do anything. If they're barely moving at all, then it's going to be a wasted power up. You probably want to find a nicer way to implement this code, but I'm not going to bother for the sake of this demo. It would get too long. So I'm going to serialize another variable here called speed multiplier. And again, I'm going to set it to 2 for the sake of this demo, but it's now available to you in the inspector, and you can change it to whatever you want. Now, as I mentioned, the only function we really need to worry about overriding at the moment is this one here, our on trigger enter. We can do it if we need to change the way that the sort of original parent class worked for one specific power up, but this shouldn't really need to change. So we really just need to look at this one here, on trigger enter. So we're going to override that. So we're going to say private. I don't think I can actually do private, can I? I'll just override. And it's a void on trigger enter collider other. And you can see my IDE, because I use Visual Studio, decided it wanted to autofill that for me and complete it for me. So based on trigger enter, what that does is that actually calls this function right here. So it's still going to disable the collider for us, and it's still going to run the coroutine for us, which is really quite nice. But we actually want to add some functionality in before that, because our parent class currently has no functionality. So I'm just, as I said, just going to increase the velocity of the object, and I can do that really easily. What I'm going to do is I'm going to grab the rigid body of the car. Now, I just for a fact know that the rigid body is on the root object. And the reason I'm using the root is because I don't know how deeply nested some of these colliders are. So I can do this. I now have the rigid body for the car, which is nice and simple. And I can do this really easily in one line. Rigid body, whoops, dot velocity. Oh, this new keyboard. We're going to multiply by our speed multiplier. So I've just taken our velocity and said double it. So 2 lines, that's all I had to do to override that class was 2 lines. Or that function, sorry. The function has been overwritten and now extends sort of this class and makes this class useful. So before it didn't actually do anything. Now I've created a new class that at least allows me to interact with this object here. So once my script loads, so what should happen is when I run through it, the car should go twice as fast. You saw it sort of took off there and flew off the edge. Let's just maximize this and see if we can see it a little bit better. So I'm sort of going sort of slowish, and you can see the car zooms off, takes off. And if I wait, it'll come back. Here we go, came back, and I can do it again. See, it's sped up there. And that's pretty much it. I've juiced this game immensely already, and what I can do if I really want, I don't have to, but grab the shield and I can grab the jump and I can add the original power up to them, so they obviously have no functionality. Look at that, now they're all spinning and moving and they just feel pretty good. They look a lot better. They're much more inviting. You sort of know that they're also, see, that one's bobbling a little too much, just going through the floor. You can also sort of tell that they're just meant to be interacted with as well. If they were static, you'd have no idea. Now look, you could add some fancy particle effects. You could add, like, what would be pretty awesome actually is just to add a little light that sort of comes out the base and shines up. You could do that really easily, like a little fog light. There's so much stuff you could do, but you don't have to, and that's the whole point of this tutorial. Spend a few minutes, spend an afternoon if you're making a game, and juice it. You know, add 50 lines of code, 60 lines of code, and make everything feel so much nicer. So I guess to everyone that watched, thank you for watching. I hope you enjoyed it. I'm going to try and make this more regular. This was a repeat video, so I'm sorry if it was a bit all over the place and a bit short. I have obviously done it before twice. The first time I recorded it, it didn't work, and then I recorded it again, and now I've decided that I need to re-record it to fix all those programming mistakes that I had. I have re-recorded this in 1080p 60 FPS, so it should run a little bit nicer. Obviously, I've actually started a new channel for those who haven't noticed as well. I do have a business. I do not do a lot with that at the moment because of uni, but this is going to be my official YouTube channel, so please, if you did subscribe before, thank you, and if you'd like to resubscribe to this channel, that would be fantastic. I've got 2 or 3 more demos that I'd like to do that I might even try to get out one more this afternoon because I have a bit of time. If not, I'll do another one later in the week. I'm going to look at how to make the camera feel really nice for this driving game because I did that for our driving game as well. And then I might even look at doing some screen shake or something similar. Really simple ideas again, but they just feel really good. So thanks for watching. Please give me some feedback. I'm aware my mic isn't fantastic. I'll endeavor to get a better one or a new one. I'm a poor uni student though, so I might have to struggle through for the first few videos. But if people like them, I'll invest in a new microphone and some new recording gear and see how we go. Thank you very much.